Welcome to Chapter 9, and this is Section 1. We're going to look at factoring by GCF. Go ahead and put today's date in the top right-hand corner. And our target for today is that I can factor a polynomial by its GCF. So first things are the factors, and factors are the numbers or variables that you multiply together to make another number. So that you multiply together to make another number. An example of this would be like if I were to ask you for the factors of 8. Well, we know 1 and 8 multiply together to make 8. And after 1 we know 2 and 4 multiply together to make 8. So the factors of 8 would be 1, 2, 4, 8, because they're the numbers that can be multiplied together to make another. Now factoring is when we factor a polynomial, we find its completely factored form. So that means we find all the factors that go into it and break it back down. For our purposes today, factoring is going to be the reverse of distributing. So distributing means we multiply together. Factoring means we're going to do the reversal and we're going to break it back apart. So factoring using the distributive property, which is also known by factoring by GCF, is for any number of terms. That means I could have 5 terms, I could have 7 terms, I could have 2 terms. So it's for any number. And just a reminder, I know we've heard the letters GCF before, but GCF is the greatest common factor. It's the largest number and variable, or variables, there could be more than one, that can go into all terms of a polynomial evenly. Now, the very first thing you're going to try if we're looking for the largest number that can go to all of them evenly is try the smallest one that you can see. Try it first and then try its factors. Alright, and then we're going to take out the variable that is in all the terms with the smallest exponent. We'll see why here in a second. Now lastly, our steps for GCF. Step 1, identify the GCF among all the terms. So look at all the terms there in the polynomial, find its GCF. 2, divide all the terms by the GCF. And lastly, your answer is written like this right here. You have your GCF on the outside of your parentheses. Then inside you have the quotient of the polynomial, because up here in step 2 where we divide, quotient just means it's the answer to the division.
Okay, so for our first example for factoring by GCF is, let's fix that. So example 1, there we go, is 36n squared plus 30n cubed. So remember, for GCF we're looking for the greatest common factor. So that's the largest number that can go into all of them evenly, and your variable that can also be taken out of everybody evenly, so it's usually with the smallest exponent. Alright, so for GCF, the very first thing I always like to check for is to see if my smaller number can go into the bigger one. So my smaller number here is 30. So in your calculators, put in 36 divided by 30 to see if that works. And 36 cannot be divided by 30 evenly, so that means 30 is not going to work. So I'm going to find the factors of my smaller number here, 30, and see which one of them can also go into 36. So 30 is, of course, is 1 times 30. We know 30 didn't work. Alright, so then we just start dividing. So we do 30 divided by 2 in your calculator and you get 15. So 2 times 15 is 30. And now we check, can 36 be divided by 15 evenly? No, it can't. So 15 is not going to work either. And remember, because we want the greatest common factor, we don't want to try 2. 2 is too small still. So we try 3 can go into 30 10 times. So 10 is our bigger number. So can 36 be divided by 10 evenly? No, that's also going to give us a decimal 3.6. So 10 doesn't work, and 3 is still really small. So let's just keep going with our factors. So in your calculator, try 30 divided by 4. It gives you a decimal, so that doesn't work. So 4 is not a factor of 30. And now we do 30 divided by 5, and we get 6. And 6 is bigger, so we're going to try the bigger number. So can 36 be divided by 6 evenly? Yes, it can. So our GCF for this one is 6. And it's just a lot of calculator work full of dividing. If you're good with your multiplication skills, and you kind of know like 6 is can go into 36 and 30 evenly, and see a little bit easier. So our GCF for this one will be 6. And then we look at their variables, see if they have any variables in common. They both have n's. And remember, I'm going to pull out the n with the smallest exponent. So we take out n squared. And the reason why we do that is because if you think about having an n squared and n cubed, n squared means we have 2 of them. N cubed means we have 3 of them. And so you want to find how many you have in common. That's the C. So you have at least 2 n's in common. So we just take out the one with the smallest exponent. Makes life nicer. Alright, so now we're going to divide everybody here by our GCF of 6n squared. So 6n squared, 6n squared. And whenever I do this next step, I like to go ahead and write my answer. So in my answer, we said we had GCF on the outside and then our parentheses with our quotient. So my GCF is 6n squared, and now we're going to divide. So 36 divided by 6 is 6. N squared divided by n squared. Remember from our quotient rules? So when we divide, we follow the quotient rules of divide coefficients, which is what we did first, and subtract exponents. So if we do the 2 minus 2, that's going to give me 0, so they cancel out. Alright, now our plus sign drops down, so plus 30 divided by 6 is positive 5. And now, because we divided our coefficients, we subtract our exponents. So 3 minus the 2 is going to be 1, so just n. And that's our answer. So our polynomial factored by GCF is 6n squared times 6 plus 5n. Now, let's say you're not for certain if you did it correctly and you just want to check yourself. So do a check. And we're just going to take our answer here, 6n squared times 6 plus 5. And since it's the reverse of the distributive property, to check it, we're just going to distribute. So 6n times 6, or sorry, 6n squared times 6. So 6 times 6 is 36, and n squared stays with it. And now 6 times 5n, so 6 times 5 is a positive 30. N squared and n to the first, add those together, we get n cubed. And the answer to the check looks like the original problem, so we're good. You don't have to show formal checks all the time, but just for this first one to let you know how to make sure you can check your work to see if you're correct. And we're all good. Now let's see another example. Example 2. We have negative 50 y cubed x to the 6th minus 10 y cubed. Alright, so GCF. The first trick I always like to do for my GCF is to take my smaller number and see if I can go in the bigger one evenly. So my smaller number here is 10. So we'll try, can 10 go into 50 evenly? So in other words, can 50 be divided by 10 evenly? And yes, it can. It gives us 5. So our GCF here will be 10. If we look at it, this guy here in front's a negative, so I'm actually going to make it a negative 10 just to get rid of that negative in front. Alright, now we go to our variables. Do they have any variables in common? So, they both have y's, and we want to take out the y with the smallest exponent. They're both y to the 3rd power, so we just take out what they have in common, y to the 3rd power. And now we look at our x's. Because this guy has an x, but this guy doesn't, x is not a GCF because he's not in that second term. Alright, so we're good. So now we'll divide everybody here by our GCF of negative 10y cubed. There we go. Go ahead and write our answer with our GCF on the outside, negative 10y cubed. Now we'll do negative 50 divided by negative 10 and get positive 5. Y cubed being divided by y cubed cancels out, and my x to the 6 just drops down. Alright, now for this one we have a negative 10y cubed being divided by negative 10y cubed. So negative 10 divided by negative 10 gives us a positive 1. And y cubed cancel, and we're good. So our final answer for this one is negative 10y cubed times 5x to the 6th plus 1. Alright, example 3. Give some more room there. There we go. So we have negative x y to the 8th, negative 7 x squared y plus 2x y squared. So GCF again. So if we look across here, we look at just the numbers in front. We don't worry about the signs. So in front of my x here, I'd actually have a 1. So I have 1, 7, and 2. So technically, the GCF there could be 1, because that's the smallest number, and 1 can go into all the numbers evenly. So 1. But like we did last time, because that guy's negative, I can take out a negative 1. Alright, so now we move on to our variables. Now, this guy has an x. I know he's a little bit hidden there. I squeezed in the negative 1 in front. This one has an x squared, and this one just has just an x. So my smallest exponent on my variable x is just x. Alright, now y. So now I have a y to the 8th. I have just a regular old y and a y squared. So my y with the smallest exponent is just a regular old y there in the middle, so y. Now our GCF is negative 1xy. I will tell you that for the most part, when you go to see these on like ACT and stuff, they probably won't show the 1. They'll make it like a negative xy, and that's because that implies there's a negative 1 there without showing it. But we'll show it for now, that way we can all see it. Alright, so I'm going to erase my marks over here. That way we can see everything. And now we'll divide. So divide everybody here by negative 1xy. Negative 1xy. Negative 1xy. There we go. And now we're at our answer with our parentheses. So our GCF is negative 1xy, and we divide. So negative 1 divided by negative 1 makes a positive 1. So those cancel out. You can show the 1 if you need to, if there's nothing else there. Our x divided by x will cancel out. And now we subtract our exponents again. So 8 minus the 1 gives me y to the 7th. And because I have a y to the 7th, I don't have to show that 1 if I don't want to. But as far as it goes for me, if you want to show the 1, that's great. If you don't want to show the 1, that's fine too. Alright, now we have a negative 7 divided by negative 1, which makes a positive 7. X squared, take away a 1x is just x. And then y divided by y, so y take away y, cancels out. Now 2 divided by negative 1 is negative 2. X's cancel. And y squared divided by y, so 2 take away the 1, it leaves us with 1y. There we go. And that's our answer for number 3. I should have said this with example 2 as well, but if you want to, you can double check yourself right now by just multiplying in your head and see if you get the right answer. So negative 1 times 1 is negative 1. And then x is x. 1 and 7 make y to the 8th. Negative 1 times 7 is negative 7. X and x make x squared. And then you have to keep your y. And now negative 1 times negative 2 makes a positive 2. X stays there. And then y times y makes y squared when we add those exponents. So you can always check yourself by just looking back at the answer without having to do a formal check. Alright, last one we'll see today is example 4. Alright, so we have 18x minus 6xy squared plus 10xy to the 9th. So, first thing we check for is our GCF, and we want to look at our smallest number first. So my smaller number here is 6. Remember, we don't look at the signs in front, just the number. So 6. We want 6. Can 6 go into 10 evenly? So can 10 be divided by 6? And the answer is no. That gives us a decimal, so we can't use that. So now we have to find, our factors of 6. So what multiplies to 6? So we tried 1 and 6. 6 didn't work. So now we do 6 divided by 2, and we get 3. So 3 is our bigger number. So now we try it. Can 10 be divided by 3? No, that gives us 3.3 repeating, and that does not go into it evenly. So 3 didn't work. So now we try 2. Can 10 be divided by 2 evenly? Yes, it gives us 5. Can 18 be divided by 2 evenly? Yes, it gives us 9. There we go. So 2 is our GCF. And because that guy's positive, we don't have to worry about making a negative. So it's just a positive 2. Now we check our variables. So this guy has an x, this guy has an x, and this guy has an x. So we can take out an x. Now this one has a y to the 9th, this one has a y squared, but this one doesn't have a y. So we cannot take out a y. Okay, so now we put our terms all being divided by 2x, 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 and we put our GCF on the outside, 2x, and our parenthesis, and we're good to divide. So 18 divided by 2, we already said was 9, and x divided by x cancels. Negative 6 divided by 2 is a negative 3. X and x cancel and leaves us with just our y squared. And now 10 divided by 2 is positive 5. X divided by x cancels and leaves us with y to the 9th. There we go, and we're all set. Once again, if you want to do a mental check and just distribute your GCF back in there, see if it looks like your answer, it would, so we're all good to go. That finishes us up for our notes. We're ready to start our practice work. Thank you.